Istio ServiceMesh. My name is Venkatramana. Welcome to DevOps with GVR. Okay. Today's agenda is we'll see what is Istio ServiceMesh. It's basically its definition. Second is its core features. Basically, Istio ServiceMesh, why it's required and what are the main features, and its architecture. So we'll see how its main high-level components and all, and service mesh related each and every component details, and we'll have a short demo. Right. So what is service mesh? So basically, in Kubernetes context, service is nothing but one particular software which is an application which serves an application, which is a microservice especially, which will be deployed, and behind the scene there will be a pod and service will work as a virtual load balancer, etc. But here it's a service mesh. Actual definition is a dedicated infrastructure layer, basically, which will facilitate service to service communication. The key point is here service to service means microservice to microservice, but whereas the service mesh, we are all talking about the Kubernetes point of view. That means it's a service to service communication. So basically it's a fast, open, reliable and secure. Then another definition is Istio service mesh is basically it's an infrastructure layer. That's a number one. Second, it's a configurable and low latency, and it will give you the facility to handle high volume of network based interprocess communication. So basically what happening is, whenever the large number of microservices, then we need to have some good configuration, and we need to have a traffic to be handled. That will be possible by service mesh. So that means we are adding another layer to the existing infrastructure, that is called as a service mesh. So service mesh is basically implemented by using a proxy. If you have here is a key point is proxy, that's called a sidecar. Sidecar is one of the pattern, which is sidecar pattern. So basically for every service instance there is a sidecar. Sidecar, basically what is the sidecar will do, we will see in the upcoming slides. But now sidecar, basically what happens is it will handle the service to service communication, which is called inter-service communication, and it provide a monitoring and security, and in an abstracted way. You have a 50 microservices, means communication will happen from its proxies, sidecar proxy. We'll see in the upcoming slides. For now, this is what is a Istio service mesh. Still we'll have another slide to understand. Right. So basically what does the service mesh will do? Service mesh will do service discovery and load balancing. So service discovery is what? Whenever a microservices are there and if you wanted to discover, you don't know 50 or you don't know 5, you don't know 100. If you want to discover, what you will do? kubectl get svc or get service, then that gives you all the list of services, and you need to understand what. And so here the service mesh will do such kind of, and also load balancing features, also intelligent routing decision between the multiple services. So if you have a 50 microservices, then you wanted to do some intelligent routing based on some logic. It's not possible with the default Kubernetes what it has, right? So basically this is the intelligent routing and encryption. So you want to add encryption within the service to service. How? Service mesh will help for you. And if you wanted to see a diagram, say 50 services, and I wanted to see how the traffic is happening, you cannot see with the, so this service mesh will provide you such kind of a option. And you wanted to monitor and trace the traffic between the services, yes, the services mesh will do. You can see live how the traffic is going on, which direction is going on, what service to what service. And service mesh will also help you to identify the issues quickly between the multiple namespaces and services in a cluster. Cluster is Kubernetes cluster. So here complete the context is with respect to Kubernetes. So here NS means namespace, SVC means service. And also we wanted to add an authentication and authorization between the services. It is servicemesh will help for you. Say you have a 50 microservices, and out of that 2 microservices require a special authentication, special security, right? Then you can add, or you can define this guy, this service can communicate to this guy. Maybe you can define such kind of policies, rules, policies with the service mesh. Resiliency. So resiliency is achievable by using this policies, service mesh policies. So especially why we use the service mesh, one of the great reason is resiliency. Services mesh is the best solution. Why? It is means it reside outside of the application. Just note down that resides means if 50 microservices are there and you wanted to configure a service mesh to leverage all these features, just you install, it will reside outside. It does not touch anything your application. It's completely an external. It's outside the and how it's possible by using a transparent proxies. So it will add a one proxy, and that proxy will help, and this is for a fault tolerance and distributed application. So these proxies will help you to achieve the fault tolerance. This is high level about the Istio service mesh. So let's get into the, so I said this service mesh concept is achievable by using a sidecar container. So what is sidecar container? Sidecar container is basically whenever a container is there, right, and you want to extend the container features, what you will do, you have to modify that container and redeploy, right? Here if you leverage this sidecar container architectural pattern, then it will add a proxy and it will extend the features of your existing container. Say this is my actual primary application which is deployed, and I don't want to touch anything, but I wanted to add some configuration, logging, some abstraction, some security features. So you need to modify this. But here if you add a sidecar, just this guy sidecar will talk to the actual application and everything is as a, so here two container, this is one container, this is one container, so something like it, that's what it's called a sidecar. It resides beside. If you look at the say you want to, there is a file system which is web server is reading, same file system a sidecar also can read, because which is in the same pod, within the pod two containers, which is one is a sidecar, one is an actual application, so that both will do. So here logging and etc, whatever the features you added to the sidecar, which will be without interrupting the actual application. That's what that's the benefit of a sidecar. So here if you look at this diagram, this is my pod is basically actual pod, right? And here is there is a logging agent and a log file. Here there is a streaming container. This is a sidecar. So this sidecar basically is reading from the log file. So something like that you can achieve by using the sidecar. You can leverage the many functionalities without affecting. That's called a sidecar. It's in a very, very simple terms. Let's go to the what is Istio. So basically Istio is a popular open source for service mesh functionality for Kubernetes, especially for Kubernetes. And why this Istio service mesh is used? To service communication. And what are the great features of Istio service mesh? One is traffic handling, second is security, third one is observability. What is observability? Observability is nothing but where you can monitor whatever the operational task, SR is to that task, and how it is implemented by using a CRDs. So CRD is nothing but custom resource definition, which is I have already created a video on the custom resource definition. If anybody did not watch, please go and watch. Maybe that video I will give you in the description. And also by using a sidecar. So we will see in the upcoming slides. So when this Istio service message started, it started in 2017 initially by Google and IBM and Lyft. So these are the main guys who started with this. Then after that it is given to the open source, right? So and current version is 1.11 by the time of I record this video. Go to istio.com, istio.io, you will see. Okay, what are the main core features, right? One is the traffic management. So what exactly the traffic management? So traffic management is nothing but traffic shifting. Say I said the 50 microservices and you wanted to shift the traffic. Say you have deployed a version 1, version 2, version 3, 3 versions, and you wanted to route the 10% traffic to one microservice, say 20-30 to the different services. It's possible with the Istio. And request writing, whenever somebody request, go to here, something like that. Request writing. Load balancing, as we know, load will be balanced and distributed to the respective services. And failover, if one will fail, other one. And with the routing rule, this routing rule you will be configuring, and you can configure ingress and egress. So in by default Kubernetes will have a ingress controller. Nginx ingress controller is an example, but here egress controller as well. So you can leverage the ingress and egress, and you can set up a retry. Say if somebody hit my service, Kubernetes service, and you can retry. In case of timeout, you can manually give a timeout. If somebody hit this service, maybe give a timeout, something like that. And circuit breaker, whatever the circuit breaker architecture is installing, that is achievable here. And fault injection. Fault injection is nothing but here you can add a fault to your service to test your service. Yeah. Second is the security, one of the main feature. As security, what it does is, between the services you can achieve TLS communication, transport level security, by using a certificate. It has its own certificate management store. It will issue the certificates, its own CA authority. It will issue and configure, everything will does for you. We just need to configure by using a YAML. And also you can achieve the access control, authentication, authorization, enforce the security policies. Here enforce is a keyword, please note down. Enforce is nothing but, say I said 50 microservices, out of that 2 or 3 microservices are very payment gateways, or maybe very highly confidential or highly core logic is happening, and you want to add a security. Yes, you can achieve by using service mesh. Observability. Observability is like a metrics, logging, distributed tracing. You can identify the basically any problem within the service, it's very quickly. Network resilience, you can check what happened with the network, where is the latency is happening, where is the slow. And also another feature is extensibility, so which is nothing but you can extend this particular service mesh functionality as per your own requirement. So basically you can policy enforce and telemetry generation for the mesh traffic. So what is this point? Maybe I will explain in the further slides. For now, this is an extensibility, the one of the feature for this. Yeah, so Istio diagram, how it looks basically. So in Istio, there will be 2 high level major components. One is the control plane, second one is the data plane. We know we deploy a pods, that's it only we know. Pod. If you have a 50 pods, 50 proxies will be added by the Istio. You need not to add, Istio will add. That proxy will go here, and that's as a sidecar. That's a one. So that's a one. Second, this is a data plane. Data plane is nothing but all the pods ultimately pods, right? Kubernetes nothing but. And control plane. Control plane is Istio's the main component where Istio specific admission controllers are running here. And Istio control plane, what it does, it has internally a pilot, citadel and gallery. These three internally exist in the control plane component as a Kubernetes admission controller that does the discovery, configuration and certification for leverage our features whatever we enjoy by using a service mesh. Yeah, if you look at the another architecture diagram, which is also the similar, but here two main components. One is a data plane, control plane. Data plane is nothing but every pod will have a proxy, and that proxy will take care of incoming traffic, outgoing traffic, and actual Istio's control plane will take care of the configuration, discovery, certification and all. So these three. Yeah. And what is this proxy exactly? It's envoy proxy. Envoy proxy is also an open source proxy which has it defined a set of sidecar container specific certain open rules and open standards for the sidecar proxy. So, and whatever this control plane component is called istiot. Here I mentioned that does this. Service mesh is basically it's a pattern, but whereas Istio is an implementation. Control plane, in the previous diagram, control plane basically converts the configuration into the envoy proxies. Of course, here whatever you configure, I want to add a security, I want to add a discovery, I want to monitor this, how it's behaving a traffic, all these things we will configure and we will tell Istio, that Istio will converts into the envoy understandable format, right? So after the configuration, envoy proxy will be injected into the pod. So basically that's how it will work. And you need not to modify your existing services or deployments in a Kubernetes. In Kubernetes, whatever your existing functionality, everything will remain as it is. Yeah. So whenever you deploy a new service or new endpoint or new pod, automatically it will detect that a new pod is added and then it will inject the envoy proxy as a sidecar. Yeah, so just we are only bothering applying just Istio configuration, and envoy will do the automation, right? Envoy proxy. Now sidecar, I said, right? What is the sidecar? Actual pod is this. A pod will have a actual business logic in this container, and this envoy proxy basically as this proxy will do the communication, security, retry, metrics, tracing. These all things is there in the our envoy proxy. That's why Istio is able to provide all these features with the help of this communication, network security setting, retry, metrics capabilities, tracing works. So these are the basic. Now let's get into the its features. All right, so this is the Istio's official website, istio.io.latest. Go to the documentation. If you look it here, Istio get started here, concept, everything is here. So now we'll see Istio's concept. If you look at the Istio concept, the feature number one is a traffic management, right? So traffic, basically how does the traffic management happens? So in Kubernetes we know the service, but whereas Istio is added a new concept called a virtual service. By using this virtual service, we can achieve the configuration of the traffic between the source and destination. Here source and destination both are the services. Destination rule. So you will be defining a virtual service first, then after that you will be defining a destination rules, how the traffic should happen. That rule will be defining. and gateways. So basically gateway is nothing but ingress gateway or egress gateway, an alternate to the Kubernetes, whatever by default is available, but ingress gateway, but it has more features than that. So by using this gateway, incoming and outgoing traffic you can control, and by using a virtual service and destination rule, you can configure a virtual service on top of an existing Kubernetes service, and then you can leverage all other features. And service entry. So service entry is another type of a kind here. Then where you can redirect and forward the traffic. Maybe you can specify, if I get a say request to the v1 service, then automatically route to v2, or automatically route to some newer version, something like that you can define. And you can set the retry, timeout, fault injection. You can, all these things you can configure by using the service entry. The sidecar, maybe you can configure your sidecar, what are the things it has to do. That also given a flexibility by the Istio. But only the thing is, you need to be very careful when dealing with the sidecar, because this will completely override. And you can set the limit, the number of services as well. So these are the core features of what is traffic splitting, etc. So, and if you look at the main request routing to the two different microservices. And fault injection means if you wanted to test, say I wanted to test my pod with with some exceptions, or maybe some say some network latency, I wanted to do the some stress test, load test, something like such kind of a faults you can add and you can test for production grade applications. And traffic shifting, basically canary deployment, right? During the canary deployment model, we will send traffic to the in a number of percentages based, right? So that is achievable. Request timeout, you can add artificial delay for the services by using this feature. Circuit breaker, you can limit the failure, latency, and proceed. So limit the failure, observe, monitor. If it is good, proceed. If not, then come back to the first stage, something like that. Mirroring, so basically you can mirror the traffic from one service to another traffic. Just copy the live traffic, so that you can say production service is running and you don't want to touch, you can do this mirror feature. And locality load balancing, so something like if that services are hosted in two different regions, then you can do the location based load balancing, same like AWS Azure load balancers we have, right? So that load balancing capabilities you can achieve by using a service. For that, your Kubernetes clusters has to be in the different regions and different availability zones where you can fail over or weighted, maybe Singapore and say Europe. So Singapore 50%, Europe is say 30%, and India 20%, something like that you can configure. Ingress gateway, incoming, egress gateway, outgoing traffic you can control. And if you look at this particular traffic flow, how it happens typically is, say this is a Istio gateway which resides in the gateway, right, where we install, and that gateway will contact to virtual service will talk to another virtual service where we define, and that will goes to envoy proxy, and ultimately, and everything between the MTLS means mutual transport level security, that we will see in upcoming slides. This is how the communication happens if you define a multiple virtual services and with a one ingress gateway. So in one ingress gateway you will define that 1 2 3, this guy database should receive from here, on this guy should receive from here, that all you can define. This is just an architectural diagram where I have taken from the internet. It's a very good, and thank you for whoever is defined this, thank you. Yeah, now ingress, how you configure the ingress configuration by using Istio Gateway, right? So you will be defining a ingress Istio Gateway. There you will define, I want public ingress or I want a private ingress, that you can define. And what happens ultimately, it will go to the sidecar and that sidecar will deal for you. It won't hit the direct service, it will be via the sidecars. In the similar way, if you define an egress gateway, means how the outgoing traffic, say this service X should not go any traffic outgoing, service X only talk to this guy only that you can define, and this B something like any outgoing you can define. Yeah, and another architecture diagram is basically here. Here from the here end user machine, Istio ingress gateway is here. So there is a book info for the demo point of view. This book info will have a service container, and this is Istio NY proxy container. This is another part, book info service. So two services, two basically sidecar container which are proxies. What happens is whenever you define an ingress gateway in the GKE cluster or maybe anywhere, first it will go to the its control plane, and control plane will talk to the whatever the underlying its internal component and talk to this sidecar proxy, and accordingly your whatever the ingress will work. This is just a visual representation how the communication, just look at the arrow marks, how this happens from it's completely bidirectional between the service proxy to. Yeah, and second great feature is here is a security, right? The security is basically one of the key feature of the Istio servicemesh. This is the most important in everywhere. So what happens is basically you can add a secure communication between the services. You want to add a secure communication means it requires HTTPS. HTTPS means you need to have a certificate. Certificate means you need to have a certificate authority and certificate server certificate and issuing authority as well, right? So here issuing Istio has own CA which they will sign, and also it will issue the certificate to the each and every service, so that the secure communication will happen, MTLS, so mutual transport level security. And if it is API, other API clients, if it is this Kubernetes services connecting, means you can leverage the JWT, is nothing but Java Web Token. So that's what it is all talking, and it has a own Istio has a own identity as well. So basically you can integrate with the Kubernetes RBAC, GCP, in Google Cloud there is a IAM service account, or in on premises you have any AD service account is there, right? That service account you can integrate, or IAM service account in GCP you can integrate, or you can define a Kubernetes RBAC and integrate here. That RBAC guy will be able to access these services, something like that. You can configure the identity. If you look at the architecture of how the authentication happens, this is authentication policy. Say here Istio pad, I define in namespace foo, I will target all. In namespace bar, this is a bar namespace, I want to target workload X. Workload Y, no, I don't want to touch. So you define by using Istio service 2, and same like that you can define authorization policies that only this guy only can talk to this guy, something like that. You can define an authorization policies, that authorization policies is nothing but who are authorized. Here authentication policy, who will be able to do this is an authorization, right? How and who, that one. So how you define authorization? So this is in a simple YAML format, everything is a YAML. So if you look at the Istio's official documentation, go to traffic management, just now we discussed, right? Request routing. Say I wanted to define a request routing. Ultimately you will define a virtual service, and you will define a V1 is a product page is a one of the service, and ratings is a one of the service, reviews is a one of the service. So something like that you end. See here here header is exact JSON. That means whoever the JSON user hits, then it will goes to the reviews and v1 v2. So something like that, everything is a YAML, right? So here this is what the authentication authorization policies. The third one is observability, which is Istio's one of the main feature, which is in the concept observability. So metrics, you can identify proxy level, control plane level. So yes, proxy and control plane level. Distributed tracing, you can identify latency, where is the problem with the communication, where is the slowness is happening, how the requests are flowing, and how you will do by using these are the two tools. Access logs, how you access the logs. So you wanted to check some service got some service is running on a port 8000 and I wanted to check what is happened, some get request happened, so you can check that with the, so it's completely full namespace with the which IP, where it hit, what time, and everything within a Apache log format, which has each and every detail, so that you can drill down what happened, where, why, who, all these things by using yeah. And if you wanted to leverage this particular monitoring feature, the one of the most important is app dot some name must be exist, which is I will show in the demo. The last feature is extensibility. So extensibility is nothing but basically you wanted to extend this particular functionality, NY proxies. What you will do is you will use a sandboxing technology. What is the sandboxing technology? Is nothing but means you are customizing the containers, customize the container calls to the Unix file system. Those are the calls you will be customizing by using a WebAssembly. And also filter the service provider interface. You can leverage the sandboxing. You can leverage the host APIs for headers, trailers, metadata, which is the advanced concept where you can call out the API, GPRS, gRPC, and HTTP calls, etc. and logging APIs, etc. as well. So these are all you can customize. If you are a developer, you can leverage, you can do the research. That's it, and we will see the demo. And demo we will do in the maybe next session. But how can you install this particular Istio service mesh? By using a bash script, Helm script, and offline as well. And for the demo point of view, there is an application called a book info. That book info will have a reviews page. Reviews page has a 3 versions, v1, v2, v3, and product detail page, product specific reviews page like Amazon. And how you will control by using the Istio service mesh to this book info application, right? So if you wanted to see the book info application, just you click on this link, it will take you to the book info, how you want to install kubectl, apply this. So I will show you in this demo. Okay, there is another application called Hipster. That Hipster also will have a multiple services, something like that. So you can define, configure all this Hipster specific app specific, and its microservices demo is available in this GitHub repository. I will try to explain how the communication happen and all, right? This is on Learn shop where you can define checkout, payment and all, right? Yeah, that's it for the today's session.